Hello and welcome to Product Popcorn, the podcast that explores topics related to product management. Most of the time. We talk with product managers and also designers and engineers that work on product teams, and only sometimes discuss the possibility of artificial intelligence taking over the world. You can always read more at productpopcorn.com. Today on the podcast, we talk about machine learning basics with machine learning engineer Kate, who is wicked smart. I say wicked because she's from Boston. I'm really excited to talk to Kate today on the podcast because I think that all product managers should have at least a general understanding of what machine learning is and how it works and what it can do for your product. After talking through the basic types of machine learning, we'll run through some product use cases. Simple stuff like recommendation engines, spam filters, sentiment analysis, and we'll talk about how these product features are powered by machine learning. Kate also explains exactly how to build a stock trading software with machine learning that can earn you millions of dollars overnight. Okay, just kidding. If we knew exactly how to do that, we would definitely not be recording this podcast right now. Hi, everybody. Welcome to Product Popcorn. I'm Kimberly, and I'm a product manager.
I'm Adam, and I am a dolphin trainer for SeaWorld.
He is, and a front-end developer on the side.
I am a front-end developer.
Guys, we have a super awesome episode today because we are going to talk about machine learning with Kate, who is a machine learning engineer. Mm-hmm. And she is basically going to tell us everything that product managers need to know about machine learning.
She's also part robot, so she's got this great insight to the thought process behind learning.
We're going to intro Kate in just a second, but just a couple of items beforehand. If everyone listening to this podcast can just share it with one person who works in tech or is a product manager, that would be greatly appreciated. Also, if you could leave us a review on Stitcher, iTunes, or Google Play, we would love it so much.
I thought, like, when you said share, I thought you were going to say shut up for a second. I was like, Kim is coming in hot on this episode.
Shut up!
If everyone could listen to just shut up.
Don't talk during the podcast. Also, disclaimer, we've said this before, but just in case you forgot, any jingling glasses are just us drinking adult beverages. And if you hear a bone fall on the wood floor, that is my dog.
Lunchbox.
Lunchbox.
The dog is named Lunchbox.
And she's chewing on a bone, so she can shut the hell up right now. So we'll see how long it lasts. All right. We're going to do Acronomicon real quick.
Oh, geez.
They are machine learning related today. So first is...
I'd like to clarify, this is the most stressful part of this podcast, is the expectation for me to come up with a description for these, but I'm ready.
I tell you them beforehand now, though, right?
Yeah, but I didn't read the notes.
Oh, great. So you're super prepared.
I think I might have read the notes.
Well, it's really easy.
Okay.
It's ML.
Which, of course, stands for Martin Luther.
Great guess. If we were talking about history. No, it's machine learning.
Got it.
Yeah. Get that a lot in emails from Kate.
I feel like I was pretty quick on that one.
It's a pretty basic one. Yeah, it was good.
Okay.
Also, another one that I thought of today is NLP, which is natural language processing. And we'll talk about that a little bit later, but I don't know. Those are kind of some machine learning acronyms. Any more you can think of, Kate, off the top of your head?
It's all acronyms in this field, honestly. You don't want me to go down that road.
Oh,
it's
we
true.
do.
It could get hard. All right. So Kate has her bachelor's in computer science with a concentration in artificial intelligence. And she also has her MS in computer science from Amherst. So she's real dumb.
UMass Amherst.
Oh, sorry, UMass Amherst.
Amherst is a place.
Do you happen to have any micro degrees? Because we've mentioned micro degrees.
You mean nano degrees from Udacity?
No. I'm talking micro degrees.
What is that? You just made that up.
Maybe like a collection of a couple nano degrees.
Don't answer that, Kate. Don't answer that question. Okay. Adam, you were supposed to do some homework
Wait, was I?
Well, yeah, because Kate has a publication titled Minimally Supervised Event Augment Extraction Using Universal Schemas. You're supposed to read that and provide a synopsis.
Oh, yeah, I got that ready.
Okay, good. We'll do it at the end of the podcast. Is that cool?
Yeah, give me a little bit to retrieve that.
All right, we'll wait so you can bring up your notes.
Yeah, I got notes on that.
Kate, you are from Boston.
Mm-hmm.
She says wicked all the time.
I say it a wicked lot. Wicked all the time.
I told you, see?
What's the best thing like to eat in Boston, like Boston specific?
Clam chowder, right?
I don't know. Don't lead the witness. We're gonna let her
I'm sorry,
answer.
I didn't mean to lead the witness by saying clam chowder is probably one of the most delicious foods on the planet.
No, I mean, I'm really glad that you said that because I don't think Boston has, like, we don't have a Philly, there's no Boston cheesesteak, like.
Oh,
Thank
yeah.
God.
Yeah, thank God. Nobody needs that.
No, we do have legit really good seafood because we live right next to the ocean.
Mm-hmm.
So clam chowder, oysters, lobster rolls.
I heard it was pronounced clam chowder. Like, that's a real thing I've heard, clam chowder.
Yes, I should have. I'm trying to mask my accent because I'm around people who are not from Boston, but it is clam chowder where I come from.
I'm from Texas, and so, like, we could have had a sweet accent battle thing going on.
No, you don't have a. Thank God you don't have a Texas accent. I don't know if we could have you.
Wait,
Every
she doesn't
week.
mean that all of our, the immense amount of
love
Texas listeners that we
Texas.
have.
One more question, and then we'll
Nice recovery.
one more question, and we'll actually talk about things worthwhile. I asked this to everybody recently, just because I'm taking a poll. But pandas or red pandas, Kate?
Red pandas.
Yes.
100% red pandas.
Oh, so happy.
I
Okay.
won't make the joke that they taste delicious.
No,
this
please don't. You've already made that joke.
You've never.
We have some
Wait.
people that are very disturbed. We were talking about tacos one time. And he's like, red panda tacos.
No.
So I was like,
Oh my
no,
God.
no, red pandas, no.
That's
They're
terrible.
endangered. All right. So Kate's a machine learning engineer. So I thought that machine learning's really important for product people to know about, even if maybe you don't even use machine learning in your product right now that you manage. Chances are that you will in the next few years, or if you move jobs, you're probably going to be involved in some aspect of machine learning or artificial intelligence. So I thought that maybe we could just ask Kate about like the basics, like what should product people know so that we don't sound like idiots when we work with engineers. So let's see. I thought that we would start out with some easy questions. So the difference between machine learning and AI, like how would you differentiate between those two? Or there's a lot of overlap, actually, obviously, but...
Yeah, there's a huge amount of overlap, and I think people tend to use those two terms interchangeably, but the way I see it is AI is a broader set of problems that go anywhere from search, like when Deep Blue, the IBM chess playing computer, beat the chess guy back in the 80s, that was AI, but it was using very efficient search techniques rather than using what we call machine learning today. Machine learning is basically just statistics in a lot of ways. It's using probabilities to make predictions about the future, and AI is a much broader set of techniques that you can use.
AI is much more terrifying.
So there are a few like different kinds of machine learning that I thought would be good to just define the difference between supervised and unsupervised learning. So can you kind of talk about supervised versus unsupervised and what the difference is?
Yeah, when I first learned about it, it was actually explained in a really good way. It's like
good.
supervised. It's if you're a student in a classroom and you have a teacher. Sometimes the teacher will give you a bunch of problems and some answers, and you try and figure out how to solve the problem, and then you can look at the answer to make sure you're correct. And sometimes the teacher will just give you a problem, and you will have no way of checking your work. And you can learn both ways. And there's the same analog in machine learning. Supervised learning is you get all the answers to all of the problems that you have, like that your algorithm has. The algorithm gets all the answers. You have them too, but it's important that your algorithm has them. Unsupervised learning is basically the algorithm explores the data, just the data. There's no answer to any problem or question.
I like that's a good way of explaining it. So, for product people, correct me if I'm wrong here, Kate, one of the most kind of classic product problems solved by supervised learning would be like a spam filter, right? Like it's either it belongs to group A or it belongs to group B. Like it's either spam or it's not spam. And the machine learning component kind of puts it into one of those two categories.
Yeah, exactly.
Is that right? Okay. Whereas unstructured is like, here's a shit ton of data and we don't necessarily know what groups it's going to put itself in, but maybe you find some clusters that you didn't expect to find in the first place.
Yeah, exactly. And you can use actually both unsupervised and supervised techniques in the same system, and you'll often do that. Or you can get a little bit of supervised data and then use an unsupervised algorithm to get part of the way to the performance you want, and then use the supervised data to inform the unsupervised algorithm. So it's very common to mix these two kinds of ways of looking at machine learning in practice.
Nice.
But
It's really cool. I didn't know that. Can you give an example of like how they would be used in tandem?
well, one thing in NLP that's very common is basically learning the statistical representations of words by having a computer basically read all of Wikipedia. So it'll, in so many words, count when words co-occur together. So
Like walk and dog.
yeah, like I walk the dog is very common together. So it'll learn kind of statistics that make the representation of walk and the representation of dog be very close together. But the representation of walk and the representation of like balloon be really far away from each other. So that's completely unsupervised. And then when you want to do something supervised, like spam detection or sentiment analysis, you'll use those word representations, and you'll have an algorithm that takes those as input and does some standard supervised learning task with those word representations, and that's super common and a super like a very well performing technique that people use all the time today.
Yeah, that's a great example. So like here's all Wikipedia. Put find the kind of words that occur together and then perform a sentiment analysis, which would be supervised because it's either positive or negative.
Sounds like my Friday night, huh?
Totally. This is what we do for fun, Adam.
Wee!
And then there's reinforcement learning. Can you kind of describe what that is?
Yeah, reinforcement learning I think is the coolest.
Is it fall into supervised or unsupervised, or is reinforcement something just different altogether?
I'm not really sure how people talk about it because that's not my area of expertise. I think a lot of the times what supervised reinforcement learning ends up being is you'll have a game like AlphaGo learn using a game, and Pong is a very common one. And so the game will provide kind of supervision. In reinforcement learning, the important thing is that you have some way of telling the computer the action you just took was good or bad. So in a way it is supervised, but there are ways of not necessarily getting tons of labeled data. But the basic idea is exactly that you just tell a computer you have these actions that you take, and then the computer selects an action to take, and then it gets a reward back that says that was a good thing that I just did or not.
Whoa, it's like a digital Pavlov.
Yes, it's exactly that.
It's literally like training my dog.
The computer's
Yeah,
mouth.
If you do the right thing, you get a treat.
The
Exactly.
computer's mouth just waters, and it's just like you gotta like sponge it up every time.
Totally.
Yes, it's always disgusting, those reinforcement learning algorithms.
And as far as like self-driving cars, is that reinforcement learning, or is that more? Is that different technique used for that?
If I worked at NVIDIA or Tesla, I probably would not be allowed to tell you how that works. I think
That's a good point.
it's so competitive, those companies working on that. But I imagine it's a combination of all three of these techniques. The supervised, they get some supervised data that's like, it looks at frames of the road.
Sure.
And the computer knows, okay, this is like, I'm in the right lane right now, and they run simulations that are labeled. There's probably reinforcement learning that tells it, okay, I got too close to the car next to me when I was changing lanes, so I'm getting a bad reward for that. And there's probably unsupervised learning that kind of segments, like when it's looking at across out the road, it needs to like recognize shapes, and so there are unsupervised image segmentation algorithms that'll just kind of pick out shapes. And it's probably all of these things are coordinating in like one very complex system that combines to make a car that can drive itself.
So, not complicated at all, is what you're saying.
Super easy to build a self-driving car. I can't believe we haven't done it yet.
Yeah. Oh, gosh.
That's
I guess
one
we
of your
have, technically.
It's one of your micro degrees.
I do not have a micro degree in self-driving cars. I would probably be making like twice as much as I am right now.
Adam is making this comment because before I had brought up that, do you know Udacity, which is like Google's online learning, and they have a nano degree in like self-driving car nano degree, and they have, it's like very specific. You should, well, you would probably breeze through it in like a month, but they also now just came out with a flying car one, which I thought was really cool too, but anyway.
Now you can take both and have a micro degree in self-driving flying cars.
This is the future.
Well, there's no
We're
point.
finally there.
As I recently wrote, tangent, very sorry, listeners, but I just wrote a blog post on the new Blade Runner movie and like how irritated I was watching it as a product manager because the product requirements written for the, humanoids or androids or robots or whatever you want to call them in the movie were terrible. And one of the use cases that I outlined was that, and this is kind of a spoiler, but not really if you saw the original Blade Runner, like they're driving the flying car. Like Ryan Gosling is driving the flying car. And I'm like,
yeah, what is this?
Okay, so you have flying cars and you're telling me you don't, and it's not self-driving? No, I don't buy it.
Even,
that's a good point.
Yeah, even in I, Robot by the Will Smith movie, he totally just like lets go of the wheel, right?
Yeah.
And there's the car's like, you shouldn't be driving right now because I'm way better at it than you.
Exactly.
Yeah, and airplanes are already like self-flying for the most part. So if you have a car that's more like an airplane, why wouldn't it like be more self-driving? That's a very good point.
Blade Runner movie producers. Poor script writing.
WTF?
Yeah, we're very angry.
Oh, I was going to ask if it was like that in Fifth Element. I think Fifth Element may even be self-driving.
Ooh, very embarrassed to say I didn't watch it. So
so that's like an older movie too. I mean, they were ahead of their time.
I know, it's very embarrassing. Okay. So we're going to go through a few product problems just so all PMs listening can kind of wrap their head around some use cases of these. So we already talked about spam detection, which is like a very basic supervised learning use case of like it either belongs to spam or it belongs to cool for you to read. And then we kind of talked about self-driving cars too. But this is one that I'm surprised hasn't actually made it to market yet is medical diagnosis.
Oh, yeah.
That would be supervised, right? Because you would actually have, technically, you would have a bunch of labels that you would label as. Mm-hmm.
Yeah. You're surprised that hasn't made it to market?
Well,
I mean, people like to sue a lot.
I know, but
so
that's why it would reduce legislation because, I mean, Kate, don't you think like a computer would more accurately diagnose a person with like less trial and error than a human?
Well, to be honest, a lot of people I've talked to think that radiology, for example, is that's very threatened by machine learning. But a more optimistic take on it is people at Oracle Labs actually, I heard, were working on cervical cancer diagnosis in Africa. So they basically have a camera that they stick up their
They're what?
You know where.
Wait. I'm confused. Where do they?
Oh my god.
Is it an orifice of some sort?
It's an orifice. But it has a camera, and they take a picture of their cervix, and then they email it to someone. But they got all this training data, label training data from doctors, and they were seeing if their machine learning algorithm could diagnose as well as a doctor, because in developing places like that, there's like one gynecologist per every 100,000 people.
Wow.
So
I've read a lot, and I actually Googled it today because spoiler for upcoming episode, we have a radiologist coming on the podcast next week. And I am so pumped about it because, as I expressed in an earlier podcast, I have so many questions about just technological innovation in medicine. But this is a really great prep for that. IBM's Watson, though, didn't it pass the radiology boards?
Oh, I don't know. I haven't looked into that specifically. I can totally see a system doing that, though.
I know that they were trying to train Watson to pass the radiology boards, but I don't know if they've actually achieved it yet.
See, this is my problem. I kind of semi-associate this with WebMD, where you're like, my throat hurts, brain tumor, right? And I know that it's not an AI and that it's just a website, but part of me is a little bit nervous that robot's gonna not have the best bedside manner.
Right. Well, this is a great segue into it all depends on how good your training data is, right? And which is a big part of machine learning. And actually, Kate should probably talk more about this, but if you have, so there was recently a big article in TechCrunch about how they were using human training data, because a lot of training data we use nowadays for machine learning, correct me if I'm wrong here, is labeled by humans, right? Like through Crowdflower or whatever technology that you have. So they were using this for loan applications, and the loan application robot, for lack of a better term, was racist because it was using, training data from humans, and humans are fallible. So how do we fix that, Kate? How do we get better training data to train our machine learning?
Well, isn't there a little bit of in that case, I feel like even in doctors, sorry, Kate, I totally just skipped just right over the top.
Don't worry, we'll get our thoughts.
I feel like there should be a certain amount of empathy that goes into making, a good doctor, a good loan,
a good diagnosis?
A good doctor, maybe not, but a good loan officer.
So that's where you could have an AI working in tandem with a doctor, where the AI is doing the actual diagnosis, because a human doctor cannot possibly just take the input, the volume of information that an artificial intelligence can. Think about all the medical journals that come out every month, 500,000 articles of new research, where you can run that through a machine and it can quote unquote learn all of that new stuff in a few hours, whereas a human could never achieve that. Then that AI could work with the doctor. The doctor can give the empathy and do all the stuff, which doctors are typically not good at anyway. And they can work though to have a more accurate diagnosis with the help of technology. So
hand in hand.
That's where I would see it going. But anyway, going back to training data, Kate, how do we what's the future of that? How are we going to get better training data so that we don't run into kind of these problems of bad, the result of bad training data can be pretty catastrophic, maybe. Sometimes.
It's a really good question, and actually one that I'm gonna have to deal with at my job, because I work with a lot of social media data and do sentiment analysis, for example. And there was an article in Vice recently even that they were testing the sentiment analysis, Google sentiment analysis API. And the sentence "I am a Christian" was had positive sentiment, and the sentence "I am a Jew" had negative sentiment.
Whoa!
What?
Yeah, I'm serious, and it's because they did some meta-analysis, and they found that like anti-Semitic people use the word Jew, whereas non-anti-Semitic people use the word Jewish, and there's some
true.
There's a lot of very specific things like that.
That is
In
fascinating.
a sad way, that kind of makes sense because people usually don't use like Christian in a derogatory manner
Yeah,
for the
you're
most
right.
part.
But I never think of it that way.
How does that make you feel being 0.2% Jewish?
I am more than 0.2% Jewish. I'm taking all the Jewish holidays too. Adam is referring to my DNA test, and it came back, and I had suspected that I had Jewish heritage, and I was extremely excited to find out that I do have not a lot. I have a part of Ashkenazi blood,
Okay.
and I was very, very pumped about it.
Yeah, Team Ashkenazi.
Team Ashkenazi.
Yeah.
Yeah.
Wait.
Let's see what sentiment that has. What do you think?
Oh,
My
that's
model would only have good ones, but
Yeah. I want to talk about, two more really quick use cases, and then I want to move on to other machine learning questions that are extremely random that I have. I'm totally using this for my own personal benefit in learning. Recommendation engines. So is that, how do those work? Like, a la Netflix, right? Like, how does this recommendation engine work? Is that supervised? Is it unsupervised? And how,
again, like there are a lot of different ways of doing recommendation, and Netflix had a whole competition. I think it's called the Netflix Prize, and people will refer to that paper, oh, that's the Netflix Prize paper. But in general, they work by counting, by just building a table of counts. So if you're a row in a table and you're a row in a table, and then they have all the columns are movie names on Netflix, they'll count how many times you liked a movie and how many times you liked a movie. And if you guys are liking the same movies with the same frequency, then they'll say, okay, some movie you watched, I'm going to recommend that to Kimberly.
that's a bad idea because it's going to be mostly Nicolas Cage movies.
You know how I love Nicolas Cage.
So good.
But you know those like extremely random, categories of movies that they have? Like they'll have the rows, each row has a genre, but it's like, future horror or futuristic tech horror with strong female lead. And I'm like, how did you come up with this? Like, do you think that they just put a whole bunch of like training data into a machine learning algorithm and had it unsupervised and see what kind of clusters came out of it? Or
Yes, clustering is a huge part of that. Okay. There are so many different ways so probably for every movie on Netflix, they have a ton of metadata, and they cluster on they can cluster on any kind of metadata attribute. So there's probably, in all those movies, there's probably a JSON field that says strong female lead, and then they cluster on that, and they have a cluster of users. They can monitor a cluster of users who like movies with strong female leads, and then what people who like other rows in the table who like Jessica Jones, they'll say, oh, you belong in the strong female lead category, and then they'll start recommending the movies that they recommend for that cluster.
And then the subcategories of strong alcoholic female leads.
that's your favorite genre, right?
Yes, I love that.
I knew it.
Who fills out this metadata? Is like the production company just like...
Well, you should know from Charter Days. We get all that
I
from...
don't.
Oh my gosh, that's gonna kill me. We worked with this company very closely.
Oh, right, it's a third-party company that does that.
And I cannot remember the name of the company, but they provide us with all of the poster art, all of the metadata for all the movies, and that's like what they do. Mm-hmm. All right, last product problem. What about, this is kind of random, but what about stock trading? So I've seen a lot of buzz around the interwebs about using machine learning to build like automatic stock trading robots, as they're calling them. How does that work? If you knew, you'd probably be like a multimillionaire, but hypothetically.
Yeah, if I knew, then I would build myself an AI that would make me rich. Actually, that's not even true, because a lot of with a lot of algorithmic trading, it's really based on reacting very, very quickly to new market conditions. So you'll have companies that are building servers right next to the fiber of the New York Stock Exchange just to get a few nanoseconds bump on their competitors. So algorithmic trading is kind of its own animal, and fintech has a lot of buzz right now, but I think the machine learning techniques they use are the same as what you would use for any other application. They probably have a reinforcement learning algorithm that is running historical simulations of how stocks have behaved, and if they make less money, they get less reward, and if they make more money, they get more reward.
Identifying trends and
Yeah, but that's a field that I really am not qualified to go into detail about, because something that happened 5 years ago is not going to be applicable today.
That's what I think makes it hard is usually you're relying on past behavior to predict future behavior in some ways, maybe, but
Kim and I were really banking on you having a lot of inside knowledge on this.
I feel like that was a
Adam quit his job today. That was me.
This
a little
is
hasty.
awkward.
No, I'm sorry to give such an unsatisfying answer to that question, but...
No, we have no idea, so any information you have is more than what we know.
Title of this podcast, How to Get Rich on Stocks Real Fast.
Warren Buffett already told us about that.
Oh, right.
Back in the Bitcoin episode.
Oh, yeah, buy ETF, buy low-cost ETFs.
That's right.
Never buy individual stocks.
Yep.
You heard it here second after Warren Buffett.
Warren Buffett's a friend of the pod. I keep advertising that. He's
that's
going to get us one day.
Warren Buffett will come after you. We've discussed this, Kim.
He's out there right now in his caddy.
He's outside the window. He's like,
What did you call it in the last episode with a very frugal sock over his face?
oh, jeez.
Warren Buffett is not a fan of Bitcoin, so we were kind of hating on him a little bit, and then we trying to work our way back into his favor.
I wasn't, because Warren Buffett's a powerful man, and don't hate on powerful people.
That's true. All right, I have a couple of other random questions. Random question 1: what the hell are neural networks? I don't know if this actually has anything to do with machine learning, but I'm really hoping it does.
Oh, absolutely. That's kind of the bread and butter of machine learning at this point.
Ooh, nailed it.
Yes. Well, specifically deep neural networks. Everyone's talking about the deep neural networks. It's been a huge trend and really transformed the industry over the last 5 years. If you look at NVIDIA's stock, that's shot up by thousands of percentages, because they make the hardware that you do deep learning on, which is deep learning is the same thing as saying I'm using a deep neural net to do some machine learning thing. And it's basically they're huge sets of matrices that when you multiply them together, they come up with good predictions about things. But in a more technical sense, they're very, very high capacity, complex statistical models. And it's kind of hard to explain what they are without going into a really boring amount of mathematical detail. But they are just capable of storing thousands of numbers and counting things in a super fancy way and coming up with really good predictions as a result of that.
So my next question that I have notated is, what the fuck is deep learning? And I guess, so deep learning and neural networks are kind of synonymous, would you say?
I think of them that way, because all of the deep learning we do is sort of, they're neural networks, but structured in different ways, and they combine counting operations in different ways. A good example is when you're doing computer vision, a common task is saying this picture is a picture of a dog, or it's a picture of a girl, or something like that. And
yes.
they take millions of images from the internet. Some of them are labeled, some of them are not, and they look at all the pixels and all these images and do different operations on them to like transform them in certain ways, and then pass them through what's called a nonlinearity to find correlations among all of these pixels that are hard to explain. It's cool if you look at simulations of how neural networks make decisions with images. That's probably the best way to explain it. But they do this over and over again, get up to higher and higher levels, and then finally have a very weird statistical representation of an image, and that statistical representation enables them to classify an image as being a picture of a girl or a dog with very, very high accuracy.
That is awesome.
Yeah,
is that what they use for facial recognition?
Yeah.
Okay.
Yeah.
And that would also be, one more. That would also be like in Silicon Valley when he's
Not
working.
a hot dog.
Not a hot dog. That's another good example. But no, when, what's the Pakistani guy's name?
Camille Nanjiani.
I know his
That's
real name. I
exact same
forget his
thing.
name. I know we never know his name in the show. But he's like looking at dick pics like over and over, trying to classify them. I mean, that's the training data for this type of thing, right?
Yes.
So, okay.
So Shutterstock uses this pixel association and correlation to return better search results, and we also do a kind of like a reverse thing where, like when you're a contributor and you're uploading images, our engine actually will recognize what you're uploading and help tag the photo for you.
Oh, like
applying
they
metadata.
automate the tagging.
Yeah, and so
That's
that you can
crazy.
say, like, you have like a better set of metadata tags so that when people are searching for your pictures, you have a higher likelihood of getting found. And so I don't know if
That's
this
really
is an
cool
industry.
application.
I don't know if this is a trade secret, so I might not have a job. So I hope you really get in on that stock thing.
If it's a trade secret, then I'll do a startup tomorrow.
Yes. I mean,
Kate
wait.
thinks it's pretty basic usage of machine learning.
It's cool. It's always a lot harder to do these things in practice than it is on paper. So
It's not a trade secret because anybody can for Shutterstock can be like a contributor. Yeah, that's what we use to for our search engine. It's like kind of amazing how smart it can get over time. It's like the machine learns, you know. It's kind of,
Yeah, that's the way I've heard it explained to me when I first started working on a product that used machine learning was like, how does a 2-year-old know what a horse looks like? It's because they see so many different pictures of horses, or they see so many horses, and the brain learns that's a horse. And so it's kind of the same way that we're training machines to recognize these kind of shapes and things.
exactly, but you've never had somebody tell you in your life, that's a horse, but that's a dog, and a dog is not a horse.
You're right.
So I think that's always interesting that process has to be very explicit with computers still. We're able to make these amazing inferences across everything we do in life, but computers, that's still something you have to hard code, like that, it has to know that there is a dog and there is a horse, and these two things are separate concepts.
I don't know. I feel like sometimes I need somebody to tell me that giant Great Dane is not a horse.
That's true. That's true.
Or just like the nuance between like a pony and a horse, or a donkey and a pony,
or a donkey and a Great Dane.
Or a donkey and a Great Dane,
Or a pony and a Great Dane. Yep.
Very similar. All right, 2 more questions, but they're heavy hitters. Where do you see this is like $1 million question, but where do you see machine learning in like 5 years from now? Like, is there anything that you're hoping to see out of machine learning 5 years from now that you think will have the ability to do that we can't today?
Well, I'm hoping to see some social good come out of machine learning rather than just enabling more advanced advertising techniques.
Yeah.
But I think really what we'll see is everything we use will use machine learning to help us do that thing better, whether it's, I don't know, driving our cars, obviously, which we see today, or I don't know anything.
I would rather not drive my car.
I don't want to. I'm so excited for self-driving cars. I know it's going to be like a serious economic disruption, but I'm pumped for it.
I'm so ready for that one time that I went in that flying car in Dubai to be a thing here.
Did not go in the flying car. We talked about this flying taxi in Dubai, which they prototyped and they beta tested it like a few months ago, and it has like a maximum charge of 30 minutes. And Adam claimed to go from Denver to Dubai in it.
It was fun. It was like super fast.
30-minute ride.
If you went up like really high in space, maybe you can triangulate.
Yeah, the whole maybe. Virgin Airlines thing. Wait, what was it? Was it Virgin Airlines that was doing like the orbital ones almost, where like they'd go way up in a plane and then just descend?
Oh, I thought that was Musk. Was it? It may have been Virgin.
I think
it was Virgin. Mm-hmm.
Oh, all right. We'll have to fact check that.
The thing with machine learning that I've heard is that it's not going to be like there's some product that is machine learning and we're all going to buy it. It's going to be machine learning is in all the products we already use. So
that is the take-home, product managers. I read somewhere that machine learning is like mobile was 10 years ago. Like it's going to be incorporated into everything. So you need to learn as a product manager how to make it work for you and how to solve your problem. And I do have a resource list up on the blog for some further reading you can read to learn what kind of machine learning is right for your product. That's pretty interesting. Goes in a little bit deeper than we're talking about in the podcast. Last question. I'm going to read it exactly how I wrote it in my notes. Does Kate think that machine learning and AI will gain consciousness one day, escape the rule of humans, and rule over humans? Mia says no. Mia's somebody else that we work with. She told me that she thinks that's ridiculous. But do you think a Westworld scenario is possible?
She didn't say anything. She just like shook her head, crossed her arms, and just like walked away.
Kate's gone now. No.
Well, I tend to agree with Mia about everything. She's quite smart. But I think, sure, there's no limit to human creativity and genius. And if we want to do something fucked up, like create a Westworld-like artificial intelligence that has feelings and emotions and sentience, then I'm sure we will do that someday. But that's a long way off because, like I said, we have to still do... we still have to do hot dog or not hot dog. That's still a very hard problem for us. So I think when you talk about, to be fair though, dialogue systems are getting a lot better now. Soon you'll probably go on Comcast and your internet will be broken and you'll chat with something and it'll seem to be human, but it's not. And
that's creepy.
Well, bots have made a lot of progress in the last year.
Yeah, it'll actually be very helpful, but also pleasant. So
and it'll pass the Turing test.
Yeah, I think we're getting close to that, honestly, with dialogue systems. I think we're getting really close.
Do you think that, like, if you were chatting with, like, an Xfinity chat bot and it was really good, if you were like, wait a second, are you a person? If it would be totally honest with you.
Well, I guess you don't train it to say anything. It would think for itself, hypothetically.
It's like, define person. You're like, oh, yeah,
shit.
Okay.
They're coming. I mean, do you ever think... Sorry, this is this kind of stuff I think about. Do you ever think that, like, maybe AIs would do a better job at ruling humans than humans do at ruling humans?
Is this a reference to our president?
To our what?
Our president?
Yeah, that's
I mean, it could be. Yeah.
Oh, wow. We just got real political. We're going to have to edit that out.
No, it's okay.
Okay.
I mean, while we're here, though, I think a lot of people criticize Silicon Valley, meaning not just people who live in Silicon Valley, but people who work in tech, as looking at tech as the solution to every problem the world has. And I think a lot of people worry that Google will be like Google government as a service in the cloud. And I used to think that that was a way to go. You know, we have certain amount of resources, tax dollars we need to distribute, and the fairest way to do that is run it through a computer, not give it to some senator and be like, oh, here's, I'll like give you a tax break on your golf course or whatever. But I think that we're so far away from computers being able to have any sense of right and wrong or even any kind of sense of complexity to
That
do something
empathy is a
crazy.
hard thing to kind of like quantify there and kind of.
It's hard to quantify it, yeah. I think.
It's impossible, I think.
Good word, quantify, right?
Yeah, awesome. Adam, do you have any last questions for Kate? This is your chance to learn about machine learning.
Mine was going to be about social security numbers. And
Kate, what's your social security number?
I like hyper focus on this, like I'm.
He asks all of our guests
every
that.
single time, but
What, my
no one answers. It's like
Honestly,
super weird.
Somebody probably already has it anyway. I'm not going to say it, but
Oh.
no, there was
It's probably best.
That's actually relevant though because I read at DEF CON, which is a hacker conference.
Yeah.
There was a talk about using a generative adversarial neural network, which is a kind of neural net that tries to trick itself. That's how it trains. It tries to trick itself to guess
Whoa.
passwords more efficiently. So it'll guess passwords that work much quicker than normal password guessing things
Oh, that's
by using proper use
terrifying.
of natural language.
Now how do I make my password secure?
No, it's fine because
Okay.
most applications are you can't guess like a billion times.
Yeah.
Stop using
Fine.
sequential characters, Kim.
All my passwords are 1, 2, 3, 4.
A B C D.
All my passwords are just Adam.
Oh jeez.
Adam 1.
Those are my passwords. You can't use those.
All right. Well, that's all we have for machine learning today. Thanks, Kate, for coming on.
Oh yeah.
Thanks for having me.
I feel like I learned a whole lot. Even though I can kind of talk to you whenever I want. I don't. I should more often. Now I'm gonna like come ask you and
Whenever.
be lots of weird questions all the time.
No, I'm happy. I'm happy to talk. I love talking.
Yay! Maybe we'll have you back for machine learning too, because we'll probably get a lot of listener questions about more machine learning questions, and then we'll have you back and you can talk about it. And we'll have Mia too.
Yeah.
All right, thanks everybody for listening. See you later. Thanks for listening to Product Popcorn. You can subscribe to the podcast or leave a review on iTunes, Google Play, or Stitcher. You can always read more at productpopcorn.com or follow us on Twitter at Product Popcorn.